Hello everybody, welcome to my class. Today I am going to discuss about a problem from linear programming. So this is a linear programming question, and actually I have drawn this question from grade 10 SCU question bank, and I am solving this because there is optional mathematics examination tomorrow, and I am not sure whether or not there will be the same question in the exam tomorrow, but at least today's class will guide the students to think in a right direction while solving this sort of problem. So here you can see actually the problem states that optimize the objective function pxy, which is given as 10x plus 3y under the given constraints. Constraints means the limitations within that boundary. So constraints 2x plus 3y is less or equals to 15, and x minus y is greater or equals to 0, x is greater than 0, and y is greater than 1. So in order to solve this sort of problem, you should have knowledge of, that means the theoretical knowledge of linear programming. So once, if I assume that you have the theoretical knowledge of this linear programming, then let's go ahead in solving this sort of problem here. So first of all, you can see here that optimize the objective function. So this is the objective function. And objective is to optimize, means to find either maximum point or minimum point or both. And then you have limitations as 2x plus 3y is less or equal to 15, and these three more limitations. And after that, the question says that also find the difference between the extreme values of the objective function. Extreme values means the end values. End means either maximum or minimum again. And so both maximum and minimum values are called the extreme values. So firstly, let's draw the boundary points. Boundary point means we take this line 2x plus 3y, alright, and instead of saying inequality less than, less or equal to, or greater than, something like that, you first of all take this the equation as the boundary line. Alright, so here you don't need to take so many points, so you have to adopt the idea or strategy that on the x-axis you know that y is 0, and on y-axis x is 0. So when you put y equals to 0, alright, then your value of x is going to be, that means 2x plus 3 times of 0 is going to be equal to 50. Is that clear? And so as this is 3 times 0 is 0, so your value of x will be here, x equals to 15 by 2. In fact, this is 7.5. It's okay. So one of the boundary point you have obtained as value of x as 7.5 when y was 0 in this case. Is that okay? And now let's try for another point so that we can meet those 2 points in order to draw the graph of the given equation 2x plus 3y equals to 15. So next, what you can see here now, let's take x equal to 0. In that case, that means you have 2 times of x, means you have 0, and then you have, this is plus 3 times of y equals to 15. Once you solve them, what you'll have actually, this is 0, and then plus 3 times of y equals to 15. When you transpose this y 3 towards the right side, then you have y equals to 15 by 3. So 15 divided by 3 is 5. So you have another point as x you have taken 0, then y was here 5. Now what you can do actually, that we have 2 points here. So first point as 7.5, 0, and another coordinate as 0.5. and this is 7.50, and this is 0 and 5. So let's go to the graph. We mark that point. So 7.5 x value is somewhere here, yes, and y is 0 over here. So this is 7.5, and y as 0. Okay, and now this point you can plot over here, that is start 0 means we are talking we are on this y axis here, x equal to 0 means, so it is 5. So another point we have is here, it is 5. So another point is you have 0, 5, and after that let's take a scale. Okay, let's take a scale and meet these 2 points. Keep your mind, keep your hand moving freely along the scale. Okay, and here I am doing on the plain sheet, but actually you try on graph paper. Okay, it must be tried on graph paper. So we have already plotted one line as the equation of line as this is 2x plus 3y equals to, it is, we have 15. Okay, this line is 2x plus 3y equal to 15. Now 2x plus 3y is a constant, yes, and according to your question it is given that this sort of thing is in fact not equal to less or equals to 15. We are saying that only 15, that means we are talking about only the boundary. This is less or equals to 15. So let's rewrite the equation in its inequality form. So it is 2x plus 3y is less or equals to 15 as it is given here. So in that case, first of all we have to find out whether its direction goes away from origin or towards the origin. That means whether it contains origin or it does not contain origin. So idea is that, so you can check here, x is greater than 0. At the boundary it is 0, at the boundary y it is 1, you can say, as it is y is greater or equal to 0. So in that case what you can do, 2 times of x value, you suppose this as 0, and plus 3 times of y value, this is 1 given at boundary, so you can write here 1, and then we have it is less or equals to 15. So this is 0, and then this is plus 3 is less or equals to 15. This is true or false? This is true. So when you find this as true, after putting this constant values for x and y inequalities, so if this is true, that means this line contains the origin. So obviously the direction of this line will be towards origin like this. Okay, so 2x plus 3y equal to 15 is the boundary point for this line, equation of this line. If you put this direction, that means there are a lot of lines you can draw, yes, but it looks so dirty, but so that we can just represent that drawing by this given arrow's head. Okay, so we have got this. Now next we have to see for another line or another constant what are given here. So you can check here that another constant is given as like this. So you have another constant, you can check here, this is x minus y is greater or equals to 0. So this is another constant given. So all these are happening together, you have to understand. So in this case, for example, your x value at the boundary point, if you just write here, it is yes. So your boundary point in this case is, or boundary line you can say here, boundary line in this case is x minus y equals to 0. It gives you y equals to x. That okay? That means you should know that to plot the graph of y equal to x means y and x are equal at every point. Okay, so what you can do, so this is 1 1, then this is 2 2, here it is the point, and this is 3 3, it is somewhere here, yes, 3 3, and similarly like that. So you don't need so many points here, 2 or 3 points will work. Then take a scale like this and then move your hand freely along those points by help of a scale. So you have this equation of line as x minus y equals to 0, which is the boundary line. It's okay, boundary line for the equation x minus y equal to 0 or y equal to x. Now in this case, what you can do, whether its direction will be towards this way or that way. So either side, if you consider, if it goes like this, it seems that it is going away from origin, and towards down also it seems like it is going away from the origin. So in that case, firstly you have to understand here is that it is x minus y greater or equal to 0 means x must be greater than 0 at every point. So look at here, if you are moving this way for example, if you are moving, y is increasing but x is decreasing. It is giving you that y is bigger than x. But from this point, this line, if you go downward, at this point if you consider x is 4 but y is nearly 2. Again if you go to another point on this line, y is 5, then it has decreased to 2. Y is 7, then it has decreased nearby to 1. Alright, so that means this sort of inequality is showing direction towards downward. Okay, so this way you can put the direction for this boundary line or this inequality, when you consider inequality, is towards downward. So in every point you can see from this point, if it moves down, then every time y is decreasing and x is increasing. That means at all point except this point, at all point after that, if it is 4, this is y value has decreased. If it is 5, y value has further decreased. So every time after this you will see that every time x value is bigger than y or y value is less than x when we consider direction below this line. And now let's talk about 2 more constraints over here. Then you have here, you can see x is greater or equals to 0. So x equal to 0, if you suppose the boundary line, so you know that x equal to 0 is the y axis and y equal to 0 is the x axis. But what it is asking you, that it is asking you that x is greater or equal to 0, so definitely we have to consider this quadrant. But another constant, so x greater or equals to 0, so we have to go to this direction. And next we have another constant given as y is greater or equal to 1. Y is greater or equal to 1, so if you consider its boundary point, that is y equals to 1. So we have to consider this line, and you should be able to draw the equation of y equal to 1. So let's check here, y equal to 1. So yes, this is the equation of the line y equals to 1 as it is passing through the value 1 on the y axis. So, and it is saying you that this is greater or equal to 1. So y is 1 is this, and greater or equal to 1 means y value will definitely go up. So at that point your direction is this. Okay, so here you will see that we have all the constraint over here, and you can see that this sort of region is now captured between all this constraint. In fact, this is the common region. So if you set all this part below this towards that direction by and also about this direction up, you will see that this side, this color is dense over there. That means this is the common region, also called, that is, this is called feasible region. Now feasible region, and we do the optimization of the thing or maximization or minimization of the thing in this common region, because this region has been captured by all the constraints. So in order to do so, from your graph you have to read off this value, but at this time because I'm not displaying the true graph over here, so I'll take the point of intersection between these 2 points. So we have equation as 10x plus 3y, sorry, this is 2x plus 3y equals to 15, and another equation as y equal to x, so this is 2x, and in place of y also we have, from this it is y equal to x equals to 15, so it is 5x equals to 15 gives you value of x as 3. So if value of x as 3, so therefore value of y is also 3, because y equal to x is 3. So our point is now 3 and 3. That means point of intersection between 2x plus 3y equal to 15 and x minus y equal to 0 is 3. And you can see in the graph, this is point 3, 3. Okay, so we have found this point. Now we have to read off this point from the graph, and also you have to read off this point from graph. Okay, so here in that case, this point you can obviously see from this graph also is that the length is 1 and height is also 1, because this is 1 and 1. So because y equal to x is every point, so this point is in fact it is 1 and 1. What is this point? It looks like 6, 1. Yes, so you can check here that this is the line. So let me check in this line, 2x plus 3. In place of y we have, because this is passing through y equal to 1, so at this point this is y as 1, and that is equals to 15. So 2x equals to here 3 minus, then it is 12. That means it is x equal to 6. So by calculation also that point is actually 6, 1. So what is this point actually? This point is 6, 1. So we have all the points available for this feasible region, and hence we can now optimize the situation. So in order to optimize that, what you have to do actually, you have to make one column, like column for x coordinate, then column for y coordinate, and then finally you have to write your objective function, which is given as pxy equal to, you can check here, this is 10x plus 3y. alright, and objective is to maximize, find the maximum and minimum value for this objective function. So that is our objective. So let's copy all the coordinates value with that bounds the given feasible region. So here you can see here that this is 3, 3, sorry, this is 3, 3. So you start from here, this is 1, 1, so x is 1 and y is also 1. And then here you can see the value of x as 6 and y is also 6. And lastly we have here x as 3 and this is 3. So you can write in any order, but we have to write the correct coordinate value. Now here this equation is 10x plus 3y. So what we have actually 10 times of x value as 1, and then plus 3 times of y value is again here 1, and then it is 10 times 1 and 3 times 1. So this is now 10 plus 3 is 13. And in another side what you can see here that this is 10 times of x value is 6, and also here it is 3 times of y value is also here 6. And now what we have actually, this is 60 and this is 80. So 6 times sorry, this is not 6, this is not 6, 6, this is 6, 1, this is 6, 1. Alright, so this value is actually 6, 6 times of 1, 6, 1, that means 10, 6, okay, 10, 6 and 3 times of 1, and that is going to be equal to, this is 60 and this is 3 times of 1 is 3, so this is here 63. Now here both the values are equal in this case, so here you have 10 times of 3 and then plus, you can check here 3 times of y value is here 3. So it is now, this is 30 and this is 9, so this is now 39. And among these values, what we can see here, that 13 is minimum. Yes, so you can write here minimum value as 13. Okay, and you have to also find the maximum value, and you can check here, the among all these values 63 is the maximum value, so you can write here 63. Okay, so we answer the first part of this question. Now the question has asked you to also find the difference between the extreme values of the objective function. Extreme values means the maximum and the minimum value. So therefore the required difference equals to, so maximum minus, this is maximum minus, this is the minimum value. So maximum value is 63 and the minimum value is here 13. So 3 and minus 3 is 0 and 6 minus 1 is 5. So the difference between maximum and minimum value is 50. Okay guys, I'm sure even in some small way it will give you insight to solve the further problems that relates the question from linear programming. Thank you so very much for watching.